Hi friends, today we are going to solve another problem on graph algorithm, building teams. So let's see this problem, what it says. It says there are n pupils in a class and there are m friendship between them. Your task is to divide the pupil into two teams such that there is no pupil in a team are friends. You are free to choose any size of the team. So what is it? It is saying like if two people are friends, they should not be into the same team. So basically, this is the problem of bipartite graph. You can search on Google also, where we need to figure out if the graph can be colored into two colors, two different colors, and no two adjacent nodes should be of same color. Okay, so same thing applies here. We have to divide it into two teams such that no two nodes are of same color. So we will create a node. We will create edge between the people who are having friendship between them. And then to find out whether we can color this graph in two color or not, we are going to use BFS. So let's say if we are on some node and there are three nodes adjacent to it, and the color of the current node is let's say one, then the color of the adjacent node should be two only. So we will apply the color two, and let's say there are there is a three node graph. Okay, so first we go to the first node, we apply color of one. There is a second node here, we apply color two, and on the third node also we apply color two. But when we go to node two to do our BFS, we will see the color of one is different, but the color of node three is same. So in that case, we need to print impossible there. Okay, so the simplest example is a graph of three nodes where each node is connected with each other. So in this case, you won't be able to provide two color. You won't be able to color the graph in two colors so that every node has different adjacent color node. So let's start the solution in C++. We'll take n and m as an input, and similar to the previous videos, we are going to create an adjacency list to create this graph. So it would be vector of in. You can say this as adjacent, and the size would be, and we'll take m inputs over here. This u and v would be the friendship between the people, so it would be a node in which there is a edge. So we will make this zero index, and then we put this in adjacency list. So now our graph is complete. So next thing we have to do is to create a BFS function, and this function will return boolean. So I will tell in some time why we are returning a boolean over here, and it will take an input as in, which would be the current node. We can call it as BFS, and in node would be the input, and we will have boolean as an output. So we will initialize a queue for BFS. Let's say it's queue. Then we will push this into uh, this node into the queue, and now we will go over the queue until it is empty. We will remove the first element and we will go over all the adjacent node of this. And we will push all of the adjacent nodes into the queue. So this is the basic structure of BFS. Now we need to do some modifications over here. For that, we will need some vectors. First would be the color vector, like what color we are assigning to some node would be of size and 0. So here 0 indicates that we have not visited this node yet. So we are not creating a separate vector for tracking whether we have visited or not. If the color is 0, that means we have not visited. And the color -1 and 1 indicate the color. And let's give the color to this node. So we can give any color in this starting node, like whether 1 or -1, anyone would work. And for every node, we are not going to directly push into the queue. Similarly, we do in BFS, like if something is visited, we do not push it. Okay. So if color of this I is not equal to 0, that means it is already visited. Else we will push it. And we will also give it a color. It would be 0 minus color of F. So if the color of F is 1, the color of I would become -1, and if it is -1, it will become 1. So there is another case over here, the put else statement. So if it is already visited, we need to check if it has a valid color or not. So according to the current condition, the valid color is 0 minus color F. So if it doesn't have this color of I is not equal to this color, then we need to do something and tell that it is not possible. So here comes the concept of this boolean. Like from here, we can directly return false. So if this function return false, that means that we are not able to color it properly. So this BFS function is complete. Now we can go to the end and we can start calling the BFS because the graph can be it is not completely connected graph. It can be in partitions also. So for int equal to 0, I less than -, we are going to call this BFS if the color is not if the color is 0. and we will get a boolean here. And if this boolean is false, then we are going to print impossible. Otherwise, we are going to continue. And after this, like here also, we need to return some boolean. So if this is complete without this return, then we can finally return true after this while loop. True means we can color it in two colors. And after this, if everything works fine, uh, we have to return from here also. If everything works fine, we need to print the color. So see out if color of I equal 1, then we will print 1, otherwise we will print 2. So the minus 1 color, we are considering minus 1 as team 2 and 1 as team 1. You can put this in brackets, I think. Yeah. Mm, like this. Yeah, it will work. So let's try to compile and run this. So here we are getting our output as 1 to 2, 1 2. There can be multiple outputs also, like if we do 2 over here and 1 over here, it will have a different output, but it will be valid also. So let's try to submit this one. Oh, sorry. So our solution has been accepted. Thank you for watching. See you in the next video.